This is a video from section 1.7 in a linear algebra class. Let's take a look at 1a. So what I'm going to do is I'm going to let A equal the matrix 2, 1, 0, 3. Now, I'm going to circle the entries along the main diagonal. And I want you to notice the entry below the main diagonal. The entry below the main diagonal is 0. And so what that tells me is that A is an upper triangular matrix. Now, all the entries, and I mean all the entries, along the main diagonal are non-zero, right? And so what does that tell me about A? That says A is invertible, right? And that's how you do 1A. 1B. We'll call this matrix capital B. Let B equal the matrix 0, 0, 4, 0. Now, what I'm doing is I'm circling the entries along the main diagonal. Remember, the entries along the main diagonal can be any number I want, right? But I want you to notice the entry above the main diagonal. The entry above the main diagonal is 0. Above the main diagonal is 0. And so since that entry above the main diagonal is 0, this says B is a lower triangular matrix. And then, is B invertible? The answer is no. At least one entry along the main diagonal is 0. So we can tell immediately whether or not we have an invertible matrix. Let's take a look at 1C. So we'll call it capital C, equal the matrix, and this one happens to be 3 by 3. So it will be -1, 0, 0, 0, 2, 0, and then 0, 0, 1/2. Okay. Now, I want to circle the entries along the main diagonal. And I want you to observe that the entries above the main diagonal and the entries below the main diagonal are all 0. Are 0, and the entries below the main diagonal are 0. And so therefore, C is an upper and lower triangular matrix. So it essentially satisfies both. Is C invertible? Are we in agreement the answer is yes? Why is it yes? All the entries along the main diagonal are not 0. Okay. And so, and by the way, one thing to take note here is this satisfies the definition of a diagonal matrix. So C is also a diagonal matrix. And so getting the inverse of C is straightforward, and then lots of things are more straightforward when you have a diagonal matrix. Let's take a look at 1D. So I'll call this guy capital D. Capital D is the matrix 3, negative 2, 7, 0, 0, 3, 0, 0, 8. And if we look at the entries along the main diagonal, right? So I always circle the entries along the main diagonal. The entries below the main diagonal are 0, right? And so if the entries below the main diagonal are 0, D is an upper triangular matrix. Okay? And then by inspection, is D invertible? No. Why no? Because at least, let me spell that again, at least one entry along the main diagonal is 0. And that's how you do 1D. Now, let's take a look at problem 3. Suppose we have the matrix 3, 0, 0, 0, negative 1, 0, and then 0, 0, 2. Are we in agreement that's a diagonal matrix? Okay. And I'm going to multiply by the matrix 2, 1, negative 4, 1, 2, 5. Okay. So this is a 3 by 3 matrix, diagonal. This is a 3 by 2 matrix, right? So the resulting matrix should be 3 by 2. Now, remember how we multiply, right? I'm taking the first row of this diagonal matrix and essentially dotting it with the first column of this second matrix. But if you notice, it equates to taking that 3 and multiplying it by every entry in the first row. So this is 3 times 2, and then 3 times 1, okay? And then what I do is I'm going to take negative 1 and multiply it by every entry in the second row. So this is negative 4 times negative 1, and then 1 times negative 1. And then I'm going to take that 2 times every entry in the third row. So this is 2 times 2 and 2 times 5. And so the correct answer here is 6, 3, 4, negative 1, 4, 10. And that's how you do problem number 3. Let's take a look at 5. Suppose I have the matrix 5, 0, 0, 0, 2, 0, 0, 0, negative 3 times the matrix. And then this is negative 3, 2, 0, 4, negative 4, right? And then I'm going to go 1, negative 5, 3, 0, 3. And then I do negative 6, 2, 2, 2, 2. Okay, so we have a diagonal matrix times some matrix A. Now, remember, if we think about it, I'm going to take that first entry, 5, and multiply it by every single entry in the first row of that second matrix. So this is 5 times negative 3, 5 times 2, 5 times 0, 5 times 4, 5 times negative 4, right? And then I'm going to take this 2 and multiply it by every entry in the second row of the second matrix. So I get 2 times 1, 2 times negative 5, 2 times 3, 2 times 0, and then 2 times 3. And then I'm going to take negative 3 times every entry in that second matrix. Negative 3 times negative 6, negative 3 times 2, negative 3 times 2, negative 3 times 2, negative 3 times 2. Just like this. Go to the next line. We get negative 15, 10, 0, 20, negative 20, 2, negative 10, 6, 0, 6, and then 18, negative 6, negative 6, negative 6, negative 6. And that's how we do 5. Let's take a look at problem number 7. Suppose I told you A is the diagonal matrix 1, 0, 0, negative 2. Okay? Now, suppose I want A squared. Okay? Now, A squared, essentially, I'm going to take the entries along the main diagonal and square them. And so I get 1 squared, 0, 0, negative 2 squared. And then if I simplify, I get 1, 0, 0, 4. Okay? Now, if I wanted A to the negative 2, okay? Now, there's a couple ways you can think of this, but I would suggest writing this as a squared and taking the inverse of a squared. But the inverse of a squared can be done pretty quickly, okay? Because all I have to do is take the reciprocal of the entries along the main diagonal of a squared. So in other words, this is going to be 1, 0, 0, 1/4. And then if I want, suppose I want a to the k, okay? A to the k is 1 to the k, 0, 0, 4 to the k, right? So I'm taking every entry along the main diagonal and raising it to the k. And by the way, k is any integer. So this is 1, 0, 0, 4 to the k, right? And I'm going to do something very similar to get a to the negative k. So therefore, a to the negative k, right, is a to the k and then taking the inverse of that, right? So I'm going to get a 1, 0, 0, and then 1 over 4 to the k. And, right? Because I'm just taking the reciprocal of both 1 and 4 to the k. Let's take a look at 9. Same thing, right? I'm gonna look at a, which is 1/2 0, 0, 0, 1/3 0, 0, 0, 1/4. Okay? And I want to do a squared. Now, what am I going to do? I'm going to take all the entries along the main diagonal and square. When I do, I get 1/4 0, 0, 0, 1/9 0, and then 0, 0, 1/16. Okay? Now, remember, a to the negative 2 is the inverse of a squared. Okay? And so I need to take the reciprocal of the entries along the main diagonal. When I do, I get 4, 0, 0, 0, 9, 0, 0, 0, 16. Okay? Now, a to the k, where k is any integer, okay, is the following. Now, I'm going to get 1 over 2 to the k, 0, 0. 0, 1 over 3 to the k, 0. 0, 0, 1 over 4 to the k. So if we go back, I'm just taking every entry along the main diagonal and raising it to the k power. But that just means I just need to take the denominator and raise it to the k. And so if I want a to the negative k, this is the inverse of a to the k. And when I do that, right, if we go back, I'm going to just get 2 to the k, 0, 0, 0, 3 to the k, 0, 0, 0, 4 to the k. So I just took the reciprocal of the entries along the main diagonal. Okay? And that's how we do number 9. Let's take a look at problem 11. Suppose I give you this matrix, 1, 0, 0, 0, 0, 0. So we have a row of zeros there, 0, 0, 3. And I'm going to multiply by 2, 0, 0, 0, 5, 0, and then 0, 0, 0. Okay? And then I'm going to take that and then multiply by 0, 0, 0, 0, 2, 0, 0, 0, 1. And I'm literally just going to go in that order, okay? Now, look at the first two matrices. So I'm going to take 1 times every entry in the first row of the second matrix. So I'm going to get 2, 0, 0, and then 0, 0, 0, and then I'm going to get 0, 0, 0 for the third row too, okay? Which is kind of interesting. And then I'm going to multiply by 0, 0, 0, 0, 2, 0, 0, 0, 1, okay? Now, when I multiply these two matrices together, right, what do you think I'm going to get? Well, I end up with 0, 0, 0, 0, 0, 0, 0, 0, 0. So this is the 0 matrix. And what you can do is you can write a 0 with a subscript of 3 by 3, because that's a 3 by 3 matrix in which all the entries are all zeros. 13. Suppose I take 1, 0, 0, negative 1 to the 99th power. This one's real slick. And this is what I love about diagonal matrices, is because all I have to do is take every entry along the main diagonal to the 99th. And when I'm done, I get 1, 0, 0, negative 1. That's it. And that's how you do, that's number 13. That's a good, I would say, that's a good stopping point for this video. This is a video from section 1.7, and we looked at problems 1, 3, 5, 7, 9, 11, and 13. Thank you.